Okay, hey guys, we're gonna do a review over quadratic attributes. So we started this before we went on break for spring break. So remember that this point here at the bottom or the top of your graph is called the vertex. And we write it as h comma k because it's a special point. So if it's on the bottom, this guy is your minimum, because he is the lowest point on the graph. And if it's at the top, this is what we call a maximum, because he's the highest point on your graph. Then the next thing we talked about was these 2 points right here where it crosses the x-axis. So the normal word that we have for that is x-intercepts, but we also have a bunch of words we can use. So is that acronym ROXS. So the R is for roots, so we can call them roots. We can call them zeros. We can call them the regular old plain old word, x-intercepts. Or we can call them solutions. All four of those words mean the same thing. Basically, it's where does it cross the x-axis. That's what it means when I ask you for roots, zeros, x-intercepts, or solutions. Then the last thing on here is this vertical line here that goes through the middle of our graph. So this is that vertical line that cuts the parabola directly in half. So remember, maybe we should write that down somewhere. Parabola is the U shape of the graph. Basically, it's just a fancy word that means the shape of this quadratic function. So that line that cuts directly down the center, that is called your axis of symmetry. And it's always written as an equation. So it's always x equals, because it's vertical, and then it's going to equal some number. And the way you find that number is you figure out, well, where does it actually cross my x-axis? That's going to give you the number that x is going to be equal to. Okay, so let's do a couple of examples. You'll have a short little practice on this in Google Classroom, but let's do a couple of examples real quick. So the vertex for this example number 1, again, this is the highest or lowest point. So that would be this blue point here. This is always a coordinate. Don't just give me 5, don't just give me 2, give me a coordinate. So if we plot this point, we're going to go from the origin, 1, 2, 3 to the left. So -3, 1, 2, 3, 4, -4. So that is my coordinate for my vertex. -3, -4. Okay, then we got to ask ourselves, okay, well, is this a max or a min? So since this is the lowest point on our quadratic, this is actually a minimum point. The axis of symmetry and the vertex are related because that axis of symmetry will run directly through the vertex every time. It's not going to be in a different place. Remember, we like to use AOS to abbreviate because axis of symmetry is really, really long to write every time. So it's always x equals, don't just give me a number. And then this is the x value that it hits, so x equals -3. Your x of your vertex and your axis of symmetry should always be the same no matter what. Okay, then we have our zeros. So another word for zeros, this is your x-intercepts. It's just a fancy way to say it. Okay. So my zeros are going to be, where do I hit the x-axis? That's these purple points. So one of them, 1, 2, 3, let's see, 1, 2, 3, 4, 5. So -5, 0. And again, these are coordinates, guys. They're not just regular numbers. So -5, 0 is one of them. And since there are two, we're going to actually write the word and in the middle of them. And then my other one is at -1, 0. Okay. Lastly, we're asked to find the domain and the range of this. So remember, domain are your x values. So all the x values your function can possibly take. So this guy right here really means you're going up forever, and you're also going left forever. Since it's left, it's going to be -infinity. This guy right here says you're going up forever also, but this time you're moving right infinity, so that's positive. So if domain is the x's, those are your lefts and rights. So this is going to be from -infinity, less than x, less than infinity. All the way left, all the way right. Another way we can write this is all real numbers. Let me rewrite that word real. Looks not like the word real. R-E-A-L. Okay, then we have range. Range is your y values, so that's going to work bottom to top. So the furthest down this graph goes is actually your vertex. That's why it's called a minimum. So for the range, we're going to use this y value right here on your vertex. So the y of my vertex is 1, 2, 3, 4. So we're going to put a y and then a 4. Now, since 4 is the minimum, that means all of your y's are above that. So it's going to be a greater than or equal to 4. Okay. Go ahead and pause the video, try number 2, see if you can get it, and then press play again and check your answers. Okay, let's check number 2. So, vertex for this one. This is the top point right here. So that is going to be at the coordinate 3, 2, 3, 4, 5. 3, 5. It's the high point, so this time it is a maximum point. Your axis of symmetry, again, vertically through half of your quadratic, half the parabola. So it's always x equals because it's vertical. And then it's actually hitting at x equals, oh, I'm sorry, I miscounted the vertex. That's x equals 2, negative 2. I did all kinds of things wrong. Sorry. Vertex is x equals negative 2. Let me check the y. 1, 2, 3, 4, 5. Yes. All right, so vertex is at negative 2, 5. So axis of symmetry is at negative 2. So that's the example. If you have two different numbers here and here, you did one of them wrong, or maybe you miscounted. These should be the same x values every time. All right, let's move on. So zeros, again, those are your x-intercepts. So we have 2 here. So one of them, let's see if I can count this time. One of them is 1, 2, 3, 4, 5, 6. So we have negative 6, 0, and 1, 0 for the x-intercepts. Okay. Domain is, again, this guy moves down forever, so that's a negative, and left forever, that's another negative. Down forever, another negative, but this time it's right forever, which is a positive. So domain is your x's, that's the left and the right. So that's going to be negative infinity, less than x, less than positive infinity. Or if you want, here's that symbol for all real numbers you can use. And then your range is your bottom to top. It's your y values. So again, find your vertex. So y, leave a space for the symbol. Use the y value of your vertex. So in this case, it's a 5. And all of my y values are below that. That's why your vertex is a maximum. Oops, that's a highlighter. Let's try this again. 5. So all your points are below it. So if this is your vertex, all of your y values are below your vertex, which means we're going to have y less than or equal to